Since the end of the 1950s, human beings have launched thousands of satellites into space. The rockets place satellites in orbit where they remain following an elliptical route around the Earth. They revolve on us at incredible speeds for several years and carry out very precise missions. For example, photograph the Earth to get weather predictions, transmit telephone, television and radio signals between two places on Earth. Or, in the case of military satellites, spy on other countries. They are controlled from Earth and are equipped with computers, cameras and sensors. Fuel, batteries and solar panels provide the necessary energy to fulfill their missions. Some spoil and others stop working when they run out of energy. They become orbital, circling around the Earth more than 27 kilometers per hour. Sometimes they collide with other objects, creating thousands of small fragments. Almost 1 million objects that measure more than 1.5 centimeters have been counted. Receiving the impact of some orbital residue is a constant threat to all our satellites and could take our society to past times if something is done to avoid it. The problem began 60 years ago. At the end of the 1950s, humanity realized that the future of the Earth depends on space. During the Cold War, the Soviet Union began the space race when it launched the Sputnik, the world's first satellite. In the National Center for Studies of Space, in France, space scientist Christophe Bonal recalls the origin of the problem. The orbital garbage problem began at the time of the first launch, on October 4, 1957, when the Sputnik Unotri's 21 days was launched. The Sputnik stopped working. It was a non-operational artificial object, which we call space garbage. The brief existence of Sputnik ended when disintegrating in the Earth's atmosphere 3 months after its launch. But the little satellite had global consequences. Determined to follow the rhythm of the Soviets, the Americans created NASA. The advance of the Soviets was extremely important for astronautics. The Soviets were the pioneers in everything, such as the first satellite or the first person in space. They put the ribbon very high for the Americans, who had to increase their missions to maintain the level. The Americans launched 17 consecutive manned missions called Apollo, 180 degrees. Prepared for expulsion. CVP, acceptable distance. At that time, no one worried to leave remains or even radioactive elements in space. Between 1967 and 1988, the Soviet Union launched spy satellites fed by nuclear reactors. But some of those satellites were defective. In September 1977, the American radars detected that the Russian satellite Cosmos 954 made erratic maneuvers. It was the first nuclear alert of the space era. On January 1978, Americans contacted the Soviet authorities in relation to the satellite. 2 days later, the Soviets confirmed that they had lost control of the device. When the satellite went back into the atmosphere, spread radioactive material through the northern Canada. The newspapers quickly echoed the fall of the Russian satellite over northern America. In that environment of the Cold War, it was clear, quickly, that space waste was a potential danger to the land of the Earth. But that was not the only danger. The launch of the satellites also creates waste. Each rocket released has left garbage in orbit. The old satellites have stayed up there, and that is what has led us to the current situation. During the space race years, satellites were not the only objects placed in orbit. Rudiger Yen, an engineer of the European Space Agency, has analyzed orbital garbage created by rocket launches. When we throw a satellite, the first phase of the rocket provides enough energy to reach the 10 kilometers of altitude and then falls into the ocean. The last phase puts the satellite in orbit, but also stays in orbit and becomes garbage. The upper phases of a rocket, next to the fuel deposits and the rocket's nose, remain in orbit systematically. During the last 16 years, many of these remains have accumulated, others have disintegrated. Space scientist Noelia Sanchez-Ortiz, in collaboration with the European Space Agency, analyzes the circumstances and destiny of orbital garbage. We place objects in orbit and think that, when they stop working, we can leave them there. So they stay there, unless they are at low height and, very slowly, end up rushing to the Earth. At low altitude, the remains move at 29 kilometers per hour, but the terrestrial atmosphere is breaking them, and when they fall to the Earth they usually disintegrate. The air molecules are compressed by the speed of these remains, which generates heat and, in many cases, combustion, making those fragments destroyed. During the day you don't see much, but during the night those burning remains look like fleeting stars. Problems increase when they do not completely disintegrate in the atmosphere. In 1997, the fuel tank of a Delta II rocket, which weighed 250 kilos, crashed near Georgetown, in Texas. In 2001, the third phase of a Delta II rocket landed 240 kilometers from the capital of Saudi Arabia, Riyadh. In 2011, the Moro of a Soyuz rocket was found in Martinica, and in 2013, several titanium deposits appeared in the garden of an electrician in Texas. Until now, no one has died, but it is a matter of time. In September 2016, the second phase of a Falcon 9 rocket crashed into a building on a small island near Java. It seems that sometimes heaven falls on our heads. As space garbage represents a threat to the population of the Earth, it has already been catalogued and its risk evaluated. We have calculated that there are 10 to 20,000 objects in orbit. Only a small percentage of these objects falls on Earth. Most of them stay there because there is no force that makes them fall. And they will stay there for a long time. Like all rocket launches are monitored, it is relatively easy to know what circulates on our heads. All satellites and waste represent a mass of 7,500 tons, equivalent to the mass of the Eiffel Tower. In the enormous extension of space, the equivalent of the Eiffel Tower, divided into small fragments, is rather as a cloud of dust. So to get a good visualization, we have to enlarge them. In the outskirts of our planet, we have a mixture of operational satellites surrounded by moving garbage. However, that extra radius is well organized. Satellites use 3 different orbits. The farthest is the geostationary orbit, a thin layer at 35,000 kilometers away. Satellites in that orbit are constantly maintained on the same point in Ecuador and are used for telecommunications, such as telephone and television broadcasts, links and television broadcasts. The satellites maintain a distance from each other about 64 kilometers. The available space is very valuable, so you have to remove satellites when your useful life ends. Their last fuel reserves are used to get out of the orbit and place in another area. The satellite moves away from the Earth to an orbit that is like a cemetery so as not to interfere with anything. Below the geostation orbit is the average orbit, located between 1,935,000 kilometers of altitude. This huge area is occupied by navigation satellites, such as GPS. If one of those satellites stop working, it is placed in an intermediate orbit where it will not interfere with others. And finally, the orbit closer to the Earth, called lowland orbit, located below the 1,900 kilometers of altitude. In that area is where the space exploration of the last 60 years has left the greatest amount of remains. And the only way to get rid of these remains is to send them to the Earth's atmosphere to disintegrate. On Earth there are several adequate areas for the re-entry of these objects and have little risk because they are so far from populations. For example, there is an area in the south of the very extensive Pacific where larger objects usually fall. If the satellite still has fuel, it is possible to control their movements in the 3 terrestrial orbits, as long as they work. But some satellites can be out of control despite having fuel. One of the problems with satellites is that from time to time they spoil and we don't know why. They work on Monday, Tuesday and Wednesday. On Thursday suddenly they break and we do not receive any notice. There is no sign that something goes wrong. Satellite operators are reluctant to talk about malfunction for not losing credibility. Most of the failures occur when nature interferes with security measures. When we analyze the causes of the problems, we find causes such as solar glows. During the solar storms, our sun releases huge amounts of energy that dispersed by electrically charged particles. The Earth's electromagnetic field acts as a shield that protects us from those particles. It is what is seen in the polar aurora. But satellites are like fair ducks, at the mercy of their effects. Solar radiation can erase its navigation systems. Despite being protected by a high-tech roof made with gold, it is estimated that solar glows destroy at least a dozen satellites every year, turning them into space garbage. The space is an empty place with waste that stays there, in motion. That causes 2 very specific problems. The first is that when they get there they stay for a long time. An object at an altitude of 950 meters, for example, can be maintained for more than 1,000 years. And the second is that, as they are in orbit, they go at speeds of 29 kilometers per hour. The probability of crashing against something at that time is really high. Until 2007, experts counted some 12 large fragments among that garbage. But since then, there are 2 causes that have made the situation get worse. One involved the Russian satellite Cosmos 2251, which began to work badly while it was in the low terrestrial orbit. The Russians lost contact with him and were unable to get him out of his orbit to lead him to the Earth. In a perpendicular trajectory to the same altitude, a new American satellite called Iridium 33 was in orbit. Thanks for watching the video. The impact spread fragments in all directions. Around 3,000 that had more than 7 centimeters and several thousand smaller thousands were launched to space, creating a threat to all devices of the land low orbit. This collision demonstrates that an object of control in the lowest orbit is a danger to all operational satellites. Another event worthy of the galaxy's war took place when China decided to deliberately destroy a meteorological satellite that was no longer in operation. Using a ballistic missile equipped with an infrared tracker and an explosive head. It was an arrogant demonstration of strength of the Chinese authorities without taking into account the consequences. Everyone talks about this Chinese test to demonstrate that it is possible to force a collision. It was done on purpose, and it was the main cause of the type of risks that we currently run. As a result of these two events, in 2010, there were more than 17 large fragments of garbage spinning around the Earth. And some of those fragments are not of satellites but of rockets. In the fuel tank of a normal rocket that places satellites in orbit, you can have a camera with liquid oxygen and another with liquid hydrogen. It is easy to remember from school that when these two gases are mixed, they become nitrous oxide that happens in space again and again. It is not used until the last drop of fuel. The excess fuel is mixed, and instead of having an intact fragment, we find thousands of pieces that remain in orbit. This garbage proliferates like a pandemic and generates even more garbage. This phenomenon is called Kessler syndrome, in honor of the NASA consultant who described him, analyzed and quantified. The amount of objects in orbit that we have at this time is sufficient for 2 years of them to clash and considerably increase the fragmentation. Don Kessler announced this scenario in 1978. Since then it has been revealed as true on several occasions. Like the collision of the Cosmos and the Iridium in 2009, it is expected that every 5 years we will find collisions between large objects and large fragments that can produce more garbage. Don Kessler also predicted that the collisions would have a waterfall effect, and each collision would increase the possibilities of more collisions. The problem occurs when an object impacts a satellite and causes a very large dispersion of particles. Especially small particles. As they are at such fast speeds, they can damage spacecraft. That, in turn, causes hundreds of smaller fragments that will collide in turn with another satellite and break it. What occurs is a waterfall effect. In 1996, when a fragment of an Ariane rocket launched 10 years before crossed the path of a French military satellite called Xeris. The blow caused Caries to destabilize about 3 meters and was out of control. Yasi extends the pandemic. Non-operational satellites and the remains of the rockets have created clouds of garbage that travel around the planet 29 kilometers per hour, creating more and more garbage. This proliferation can endanger many activities on Earth. It is easy to forget that satellites are fundamental in our daily lives. We use our mobile phone to look for a place, know how long it will take to arrive and what is the best route to arrive. When we are traveling and we get money from a bank, we can be using telecommunications satellites to communicate a bank in the United States with our bank in Europe. It is difficult to imagine life without smartphones, bank cards or GPS systems. We could not live without satellites. And the proliferation of space garbage is endangering those services of the satellites that constantly diversify. Space agencies have to assume large risks every time they perform a launch, including the European Space Agency. If we wait for the time when everything is empty, that would imply that we could not make any launch. So, even if it is difficult to believe, we are doing it despite the possibilities of colliding with something. If we did not do so, we would never have green light for a launch. The current risk is demonstrated and calculated. The chances of losing a satellite are 5%. A risk percentage refers to receiving the impact of some rest of the trash. There are very complex components that can be broken, causing the satellite to be unusable. But the possibilities of losing a satellite quickly reach 10 or 20% by increasing orbital garbage. The European Space Agency estimates that the risk of collision will increase to 20% in 2038. That is, 1 in 5 satellites will not complete its mission. It is a very high percentage. Space agencies should look for ways to overcome this minefield and detect the remains in orbit. Since 1957, the United States has been using a spatial surveillance network to predict when and where spatial remains will enter the Earth's atmosphere. They have created a catalog of remains that are in orbit and use it to determine to which country the objects that enter the atmosphere belong. It also allows NASA to be notified if there is a risk of interfering with its own satellites. Over time, when artificial objects are multiplied in orbit, this system has been improved and computerized. But in Europe, a similar spatial surveillance system was not established until 40 years later. In 1996, when the remains of the Ariane rocket damaged the Ceres military satellite, the French defense minister implemented a system called Reakers. The record system, a spatial surveillance network, is our main sensor and allows us to detect objects in orbit between 400 and 950 kilometers of altitude as long as they are large enough to be detected by the radar. In other words, have the size of a lamidora. To detect satellites in orbit 950 kilometers on France, even on cloudy days, the system uses a certain radar that makes real-time calculations to follow and anticipate the trajectories of thousands of satellites. The record system was able to detect about 30 spy satellites from the United States and China that had not been previously catalogued. Today, international relations in space are a mixture and an extension of those lived on the surface. In other words, there is as much mutual help as competition and sometimes open clashes. France agreed to remain silent about spy satellites, but in return he got access to the United States orbital trash catalog. This catalog is much more thorough than the European version, since it collects objects that only measure 10 centimeters. We have managed to handle the problem of small objects thanks to the collaboration between France and the United States, which even provides us with confidential level information. This constant spatial surveillance is very efficient and allows military and civil satellites to avoid collisions with orbital garbage. If there is a risk, Earth operators can slightly move satellites outside the collision orbit. These maneuvers are increasingly performed, especially in relation to the largest satellite of all time, the International Space Station. This inhabited satellite is found several times a year threatened by remains of space garbage. To avoid that orbital that follows an already identified trajectory, the space station has to deviate from its course. In 2012, he avoided a fragment of the collision between the Iridium and Cosmos satellites occurred 3 years earlier. In 2014, the space station had to avoid the moving space trash 5 times. This constant threat has become part of the daily life of astronauts. The space station is on the collision route of a small fragment of space garbage. They have informed us from the ground. They know it thanks to radar systems. To avoid the impact, my watch is whistling with an alert. We have to move the station to an upper orbit. To do this, we are going to light the engines for 37 seconds. It is the only time we can perceive the sensation of acceleration while we are on board. Suddenly we no longer feel as if we did not weigh and the action of the engines pushes us back. Let's start. Forward. Let's go there, the game begins. Come on, start the game. Sometimes, ballistic data on these remains are not exact. In those cases there are no risks and the astronauts are ordered to evacuate the station immediately. They take refuge in the escape module that can be separated from the station and allows astronauts to return to the Earth. But evacuation is not always necessary. There are often orbital waste that is not detected if they measure less than 10 centimeters. There are currently millions of garbage fragments that are too small for radars to follow them. To avoid this threat, satellites and space station need protection. In Freiburg, Germany, the scientists of the Fraunhofer Institute try materials that serve as a shield using a super-rapid accelerator called space cannon. This space cannon shoots small metal balls against various protection materials. This series of cameras reproduce the space conditions. They are full of light gases and accelerate the balls at the same speed as orbital garbage, 29 kilometers per hour. At this speed, the behavior of collisions is very different from the one on Earth, for example, in a car accident. When a car hits a wall or against another car 50 km per hour, thousands of fragments are deformed and created. But to hypervelocity, a speed above 10 km per hour, a collision generates a different physical phenomenon. In a high-speed impact, the particle is fragmented, so some parts are vaporized and ionized. There are others that cannot support the enormous subsequent pressure after the impact wave. To hypervelocity, a millimeter ball has more energy than a baseball ball 100 km per hour. The laboratory is protected by reinforced doors and a high-speed camera that records more than 1 million photograms per second records the time of impact. As security caution, no one can remain in the room while shooting the space cannon. Subsequently, the results of the tests on the different components of a satellite are analyzed. For the International Space Station we have tried several shields, but we also tested its components, such as solar cells or deposits that are used inside the satellite. Using ultra-chamber images, the space cannon equipment manages to understand and create a model of what happens during a collision. Their work allows them to create structures that are at the same time light and resistant to hypervelocity impacts. They have shown that bending or tripling the insulation layers, the components of the satellites beaten by fragments of less than 10 centimeters can be protected. The first layer breaks the fragment that impacts. The second dissipates its energy and protects the third layer. Thanks to these experiments, scientists have been able to design satellites resistant to small garbage fragments. But we still can't protect astronauts when they are out of their vehicle during spacewalks. They are exposed to small fragments that by their speed cannot be detected by radar or seen by the human eye. The slightest impact could pierce an astronaut's suit and cause immediate death. Due to this risk, NASA is developing robots that can replace humans to perform maintenance tasks outside the spacecraft. Although robots could not bear the impact of a greater object of 1.5 centimeters. Obviously, the less garbage there is, the better. Many countries have tried to establish rules to avoid the proliferation of space waste, just as they have done with nuclear weapons. For example, satellite operators are asked to empty all the fuel that is left in them. All rockets are equipped with systems to expel or burn excess fuel. This system is checked before each launch. Satellites have a useful life limited to 25 years in orbit. And finally, the objects in the low terrestrial orbit that do not disintegrate when resenting in the atmosphere must be directed to wide areas of the ocean for the final impact. However, these rules are not respected on all occasions, especially since there is no agency that sanctions those who do not follow them. And as time passes, the amount of garbage increases. We are generating spatial remains more quickly than we can clean the atmosphere. We call this a non-sustainable environment. There is only one real solution for this problem. Collect all that garbage that orbits around the Earth. It is necessary to recover some of the objects that we have left in orbit. Based on the idea of pollution quotas, it is about each country from financing the elimination of its own garbage. Since 2013, aerospace engineers have created a new profession, space garbage. The idea is to create robotic systems that can handle large pieces of garbage and send them to an incinerator, the Earth's atmosphere. The difficulty of the task is that orbital trash moves like an asteroid, turning because of gravity. Laboratories around the world are preparing robotized satellites that can capture the garbage and remove it from orbit. That is working on the waste elimination project at the Surrey Space Centre, in England. In a real mission you have to handle an object that does not make it easy because it may be turning. Aerospace engineers use technical terminology, but their project seems rather a children's game. One of the technologies we use in our mission is the harpoon. It seems strange, but the team is developing a harpoon capable of getting hooked on a piece of garbage to drag it towards the atmosphere. In our mission to collect garbage, what we do is test the effect of the impact of the harpoon on a target, a plaque. The team is still in an experimental phase, testing a miniature harpoon about a static objective. First attempt. 3, 2, 1, ignition. Failed. The harpoon has not left its pod because of an electromagnetic problem. Second attempt. We hope the harpoon impacts exactly where we want it to impact. 3, 2, 1, ignition. He has failed again. If the harpoon does not impact the center of the objective, it will not be able to capture it. According to scientists, the hunting of remains should be easier in space than on Earth. When we are in space, thanks to the lack of gravity, alignment should be much better than in the tests we do on Earth. The test and error method is a very long process, but step by step, the equipment is improving its system. The first real-scale tests in space will be held in 2020. The harpoon is not the only tool conceived by aerospace engineers. The South African Space Agency, created recently, in 2010, has prepared its own cleaning solution and hopes to sell it later. One of its projects includes building a small satellite capable of displaying its tentacles to capture the remains. His name is Medusa. Medusa will wrap the object and drag it, moving it where necessary, so that it changes orbit, so that it descends from altitude, or to take it to the atmosphere and let it disintegrate in the re-entry. Another advantage of Medusa satellites is that they can be launched directly from the International Space Station. Medusa is very light. It weighs about 175 grams and is designed to be mounted from CubeSats. A CubeSat is a small satellite in cubic multipurpose that measures about 10 centimeters. It has been developed by a Californian university and many can be launched at the same time, which reduces costs. They are a blessing for researchers who have no other way to perform experiments in space. Boarding CubeSats, a concept already in use, Medusa could be able to eliminate garbage for 25 years. At this time there are many proposals, such as harpoons. Some can only be used once, unactive, and if you fail. What makes Medusa a unique system that allows multiple attempts to be made? The idea is to use it many times to eliminate small objectives. The inconvenience of Medusa is that it only works with small remains of space garbage. For large satellites that do not work, it is necessary to use other tools, which opens a financing problem for these operations. Unfortunately, none of these solutions is prepared to be used. No one is willing to pay the high price to eliminate orbital garbage. The higher, the more problems it will cause, because any damage you suffer will create more garbage. The largest non-operational object is the Invisit, an observation satellite the size of a bus. It was launched in 2002 by the European Space Agency. At that time, the agency was trying to get the greatest benefits of its investment. But currently Rudiger Yen distances himself from the decisions of his predecessors. They wanted to maximize the benefit. They used to the last drop of fuel for their operations instead of using a part to remove it from the orbit. That was the problem. When it was built, it was the largest observation satellite ever built. After 5 years of activity and 50 orbits around the Earth, they should have taken it out of the orbit. But their operators decided to expand their mission. However, 10 years after its launch, on April 8, 2012, the European Space Agency lost control of the Invisit. At this time it is like a watchmaking pump. Cross trajectories used by satellites that are operational. No. The situation is so critical that the European Space Agency is preparing an ambitious program to get the Invisit from its orbit. We think that launching a network could be an option because that would allow to have a connection, a tie with the satellite that would allow to pull it once captured. To test this space network, engineers use an airplane in which they recreate the conditions of lack of gravity of the space. At the highest point of this parabolic flight, in the form of a bell, passengers and objects are free from earthly gravity for a few seconds. Enough time to try a miniature version of the network that they will use to capture the 8-ton satellite. The tests have revealed that adding weights in the corners of the network allows to capture the satellite body without getting hooked on its fragile solar panel. Now, they have to build a tractor satellite that can tow the Invisit and lead it to their destination. Invisit weighs 8 tons. It is a lot of heavy than the vehicle that pulls it. When you have to move something heavier than yourself, it is better to throw away. It is a more stable situation. Despite being essential for space security, this project is still in the theoretical phase. For a simple reason. We have studied the problem to find a solution, but it would cost 500 million euros. For technological and economic reasons, there is still no prepared robotic garbage. To work, the cleaning operation should be free, as if it were an additional passenger on a mission. What seems very promising is what we call space tug. The space tugboat would have to be multifunctional, a kind of space Swiss razor. On Monday, you will recharge a satellite, on Tuesday it repairs another, on Wednesday reviews a satellite, Thursday performs maintenance and Friday returns to Earth. And when he returns to Earth, he could collect some space garbage and send it against the atmosphere. However, according to Airbus engineers, who are developing space tugs, there are still technological problems. What we cannot do now is a scheduled encounter with an object that has not been designed with that purpose, such as an old satellite or a fragment of space garbage. A meeting is an organized and controlled contact between two space objects. We need to develop new autonomous technologies that could manage stress based on vision sensors that would scan the environment and analyze the contents of the images they capture. The analysis of the data would detect the parts of the objects that interest us to be able to capture and manipulate them. The Space Tug project is still under study. But thanks to the high financing he has achieved, the first efficient cleaning system could be in use in 2025. In addition to the European Space Agency and the Invisit, space tugs could find more customers. New and ambitious emerging companies plan to send thousands of satellites to the low-land orbit to create a broadband internet network around the world. One of these projects, known as Megaconstellaciones, became a reality in 2017, the OneWeb project. A visionary entrepreneur managed to convince some American internet giants, in addition to the European Airbus company, to make huge investments in the manufacture of a series of almost 1,000 satellites. Its objective: guarantee internet access from the most remote areas on the planet. OneWeb has designed, is building and will soon launch a satellite constellation to end the digital gap. Will provide broadband access to half the planet. To the 4 billion people who currently do not have that access. In the initial constellation we will have 882 satellites. It is almost the number of operational satellites that are currently in orbit. And this huge amount is a source of concern for orbital garbage specialists. There are projects for new megaconstellations, for example, OneWeb, and we are not talking about having 100 satellites but 1,000. Boeing, SpaceX, there are many new participants in the market that have new ideas and want to launch satellites. In the end, everything will become space garbage. It is a big problem. Where does all this go? The promoters of these gigantic projects argue that they have taken all the necessary precautions. There are some issues on which we have to think very carefully. We must create some type of normative environment so that satellite operations are carried out in a way consistent with the long-term use of space. There is also the danger of filling the space with even more garbage. If there are failures, if there are satellites that are broken, they will continue to spin as garbage. That is my concern, that there will be more space garbage. It is well known that people leave waste in their path. To avoid orbital garbage pandemic, it is urgent that there are international standards. There is still hope. Most people involved in space exploration are demanding it. We are concerned that there is no international organism to regulate it. There are several groups thinking about regulating it, and some countries have different ideas about regulation. But nobody is shaping those ideas. The solution will have to come from the United Nations, legislating and demanding people to get involved in cleaning the space. While we hope a pollution quotas system is applied to space, orbital garbage is a great concern for satellite operators. Although there are few people who are aware of the problem, one day, shortly, our lives could begin to turn uncontrolled.